Good morning, dear students. Today we are going to study a very important topic of pharmaceutical inorganic chemistry, antimicrobial agents. This topic comes under Unit 3 under the category of gastrointestinal agents. Let's start the topic. Antimicrobial agents. Antimicrobial agents are the chemicals or drugs or their preparations which help in reducing or preventing the infection caused due to pathogenic microorganisms like bacteria, virus, fungus, protozoa, etc. Antimicrobial agents belongs to various categories like antiseptics, germicides, sanitizers, disinfectant and sterilization, etc. Antiseptics. Antiseptics are the agents that prevent sepsis by destroying or inhibiting the growth of microorganisms on the living tissues. An ideal antiseptic should destroy bacteria, spores, fungi, virus, or any other microorganism without causing any harm to the tissues of the host. Antiseptics can also be used in the prevention to the hands of surgeons, dentists, nurses, and others in their routine procedure. Antiseptics examples are hydrogen peroxide, potassium permanganate, iodine, povidone iodine, etc. Disinfectants. Disinfectants are basically the substances which prevent infection by the destruction of pathogenic microorganisms and are generally employed for inanimate or non-living objects and materials such as instruments, rooms, hospitals, home equipments, etc. to get rid of microorganisms. All the disinfectants are basically bactericidal in nature. Examples of disinfectants includes chlorinated lime, potassium permanganate, formaldehyde, phenol, etc. Germicides. Germicides are the substances or agents which are having killing property, that is they basically show their antimicrobial action by killing various microorganisms like bacteria, virus, fungus, protozoa, etc. They are basically used at higher concentrations or at higher doses. Depending upon the type of microorganism that they kill, they can be of various types like bactericide, which is used against bacteria, fungicide, which is used against fungi, virucide, which is used against virus. Next term is bacteriostatics. Bacteriostatics are the agents or compounds or substances which primarily works by inhibiting or preventing the growth of bacteria. That is, they do not kill or they do not have cidal property, but they only stop the growth of bacteria. Sanitizers. Sanitizers are the disinfectants that are used to maintain the general public health standards. Sanitation is basically concerned with cleaning and washing away organic matters like saliva, mucus, etc. Sanitizers are having the power to kill microorganisms and at the same time they do not cause any local cellular damage. Sanitation is mainly concerned with the cleaning and washing away the microorganism. Sterilization. Sterilization is the process of complete destruction of all microorganisms including bacterial spores. They can be done by two types, that is by physical method via application of heat or radiation, or by chemical means, that is by the use of certain chemical disinfectants. Characteristics of antimicrobial agents or ideal properties of antimicrobial agents. An ideal antimicrobial agent should be chemically stable. That is, it should not get degraded in the presence of chemicals, enzymes, radiation, etc. An ideal antimicrobial agent should be economical so that it can be afforded by all. It should have rapid onset of action, means as soon as it enters inside the body, it shows an immediate effect and it should have sustained activity or its activity gets retained over a long period of time. It must have good therapeutic index, means it should have a broad spectrum of activity, or it should be able to kill a wide range of microorganisms like bacteria, virus, fungus, etc. It should not cause any local cellular damage, or it should not be irritating to the tissues on which it is applied. It should not produce any toxicity, or it should not cause any side effects to the body. It should have favorable absorption or partition coefficient, and it should be able to reduce the development or incidence of resistance in microorganisms. Classification of inorganic antimicrobial agents. Inorganic antimicrobial agents can be broadly classified into four types. First one is halogens. Examples of halogens include iodine. Iodine 2%, 3% or 5% in alcohol solution. Povidone iodine, Lugol solution, chlorhexidine. Oxidizing agents. Examples of oxidizing agents includes hydrogen peroxide and potassium permanganate. Third one is acids and alkalis. Examples of acids and alkalis that are acting as inorganic antimicrobial agents includes boric acid, salicylic acid and solution of ammonia. Metallic salts. Metallic salts acting as antimicrobial agents includes silver nitrate, zinc sulfate, zinc oxide and copper sulfate. Targets of antimicrobial agents. An antimicrobial agent can show its antimicrobial action or effect by the inhibition of cell wall synthesis, or by the inhibition of protein synthesis, or by the inhibition of nucleic acid like DNA and RNA synthesis, or via inhibition of metabolic steps in microorganisms. Mechanism of antimicrobial action. An antimicrobial agent basically acts or shows its antimicrobial action or effect via three mechanisms: oxidation, halogenation and protein precipitation. Oxidation. Compounds acting by oxidation mechanisms belong to a class of peroxides of peroxy acids, oxygen liberating compounds like potassium permanganate and certain oxohaloanions. These compounds basically act on the proteins containing free sulfhydryl groups. They act on the free sulfhydryl groups of the protein and convert this group into disulfide bonds, due to which the shape and conformation of the protein gets altered or changed, and due to that this protein is not able to perform its function properly, that causes the destruction of microbes or microorganisms. Halogenation. Compounds which liberate chlorine or hypochlorite or iodine basically act by this mechanism. This category of agents act upon the peptide linkage and alters its potential and property by the insertion of halogen into the peptide linkage. This causes destruction of specific function of proteins that leads to the death of microorganisms. Protein precipitation. Examples of the compounds that are acting by protein precipitation mechanisms are the antimicrobial agents having metals in their structures like AgNO3, ZnSO4, etc. They are also known as astringents. Many metals in their cationic form exhibit the property of protein binding or protein precipitation. The nature of interaction with proteins occurs through polar groups of proteins like NH2 and SH groups, etc., which acts as ligands or Lewis bases, and the metal ions in the antimicrobial structure which acts as Lewis acids. The interaction takes place between the ligands and the Lewis acids, leading to the formation of coordination complex or a chelate, which may be strong, that leads to the inactivation of proteins and inactivation of microorganisms. Hydrogen peroxide. Molecular formula is H2O2. Molecular weight is 34 gram. Preparation. Hydrogen peroxide is prepared by the action of sulfuric acid on barium oxide. that is BaO2 plus H2SO4 gives BaSO4 plus hydrogen peroxide. Hydrogen peroxide may also be manufactured by treating sodium peroxide with dilute sulfuric acid. That is Na2O2 plus H2SO4 gives Na2SO4 plus H2O2 or hydrogen peroxide. Hydrogen peroxide is also obtained by the decomposition of barium peroxide with phosphoric acid. 3BaO2 plus 2H3PO4 gives barium phosphate plus hydrogen peroxide. Hydrogen peroxide may also be prepared by passing CO2 or carbon dioxide through a suspension of barium peroxide in water. Reaction is BaO2 plus CO2 plus H2O gives hydrogen peroxide and barium carbonate. Properties of hydrogen peroxide. Hydrogen peroxide occurs as colorless, odorless liquid having a slightly acidic taste. It acts as a strong oxidizing agent. Hydrogen peroxide is decomposed in the presence of oxidizable organic matter, and its decomposition is promoted by metals and catalysts like copper, iron, manganese, etc. Decomposition of hydrogen peroxide gives water and liberates oxygen. Hydrogen peroxide causes oxidation of various inorganic agents like Ki. Ki in the presence of hydrogen peroxide is oxidized to form potassium hydroxide and liberates iodine. Sodium sulfide in the presence of hydrogen peroxide is oxidized to form sodium sulfate and water. Assay of hydrogen peroxide. Hydrogen peroxide and potassium permanganate both are oxidizing agents and reduce each other with the evolution of gaseous oxygen. Hydrogen peroxide reduces KMnO4 solution and causes its decolorization. At the end point, excess drops of KMnO4 gives pink color, and here KMnO4 itself acts as an indicator. This assay is based upon volumetric titration method, where 10 ml of the sample is diluted to 250 ml in a volumetric flask with purified water. To the 25 ml of this solution was added 10 ml of 5 normal sulfuric acid, and the whole content is titrated with 0.1 normal KMnO4 solution until pink color was obtained. Uses of hydrogen peroxide. Hydrogen peroxide is used as a strong oxidizing agent. Hydrogen peroxide is used for cleaning of cuts and wounds as an antiseptic. Hydrogen peroxide is used as a strong antiseptic and germicidal, and it destroys all pathogenic bacteria. 6% solution of hydrogen peroxide is used as disinfectant. Hydrogen peroxide is also used as deodorant and bleaching of the hairs. Hydrogen peroxide is used as antidote in phosphorus and cyanide poisoning. Chlorinated lime. Chemical formula of chlorinated lime is CaOCl2. Preparation. Chlorinated lime is prepared by the action of slagged lime or calcium hydroxide on chlorine gas to form chlorinated lime. Properties. Chlorinated lime occurs as a dull white powder. It is having a strong smell of chlorine. It is having a characteristic odor. It is slightly acidic in water and alcohol. Auto-oxidation of chlorinated lime gives calcium chlorate and calcium chloride. In the presence of cobalt chloride, chlorinated lime decomposes to form calcium chloride and liberates oxygen. Chlorinated lime in the presence of carbon dioxide and water forms calcium carbonate and calcium chloride. Uses of chlorinated lime. Chlorinated lime has a strong bactericidal action. It is used as a disinfectant in wounds. It is used as a cleaning agent for toilets, drains and effluents. It is also used as an ingredient in the preparation of detergents. It is used as a bleaching agent and is used in decolorizing most dyes. It is used in the preparation of chloroform. Properties of hydrogen peroxide. Hydrogen peroxide occurs as colorless, odorless liquid having a slightly acidic taste. It acts as a strong oxidizing agent. Hydrogen peroxide is decomposed in the presence of oxidizable organic matter, and its decomposition is promoted by metals and catalysts like copper, iron, manganese, etc. Decomposition of hydrogen peroxide gives water and liberates oxygen. Hydrogen peroxide causes oxidation of various inorganic agents like Ki. Ki in the presence of hydrogen peroxide is oxidized to form potassium hydroxide and liberates iodine. Sodium sulfide in the presence of hydrogen peroxide is oxidized to form sodium sulfate and water. Potassium permanganate occurs as dark purple prismatic crystals with a metallic luster. It is odorless and is having a sweet and astringent taste. It decomposes at higher temperature, that is at 240 degrees Celsius, to form potassium manganate, manganese dioxide and oxygen. Potassium permanganate is freely soluble in water and alcohol. Potassium permanganate acts as a strong oxidizing agent involved in various oxidation reactions. It oxidizes iodide to iodate and iodine. In alkaline and neutral medium, potassium permanganate oxidizes potassium iodide in the presence of water to form manganese dioxide, potassium hydroxide, and potassium iodate. Whereas in acidic medium, potassium permanganate oxidizes potassium iodide in the presence of sulfuric acid to liberate iodine and form manganese sulfate, potassium sulfate, and water as well. Potassium permanganate oxidizes aldehydes to form carboxylic acids. Uses of potassium permanganate. Potassium permanganate is used as antiseptic in mouthwashes and for the cleaning of ulcers. It is also used as disinfectant and deodorant. It is used as a topical anti-infective agent. It is also used as a bleaching agent in water treatment. It is used in urethritis or inflammation of urethra. It is used as an antidote in poisoning of barbiturates and alkaloids. It is used in dermatitis or skin infections like eczema. It is used as oxidizing agents in various chemical reactions. Boric acid. Chemical formula is H3BO3. Preparation of boric acid. Boric acid is prepared by the action of borax with a mineral acid like HCl, where borax reacts to form boric acid, sodium chloride, and water. Boric acid may also be formed as a byproduct of hydrolysis of boron trihalides and diborane. In laboratory, boric acid is prepared by the action of sulfuric acid on water to form sodium sulfate and boric acid. Properties of boric acid. Boric acid occurs as colorless, odorless, white crystalline powder. It is slightly acidic in nature and is having a bitter taste. Boric acid is soluble in water and alcohol, and it is stable in air. Its 1.9% solution in water is isotonic with the serum. On reaction with sodium carbonate, boric acid forms borax, carbon dioxide, and water, whereas on reaction with calcium fluoride, boric acid forms boron trifluorides, calcium sulfate, and water. Boric acid, when heated, undergoes decomposition and dehydration to form metaboric acid, tetraboric acid, pyroboric acid, and boron trioxide. Boric acid also dissolves in glycerine to form glyceroboric acid. Boric acid reacts with alcohols to form borate esters like ethanolic solution of boric acid when heated gives ethyl borate that burns with green edge flame. Uses of boric acid. Boric acid is used as an antiseptic for minor burns, cuts, and in the treatment of diaper rashes. Boric acid acts as a weak bacteriostatic and fungistatic agent. Boric acid aqueous solution in the concentration of 2.5 to 4.5% is used as an eye wash, mouthwash, and skin lotions. Boric acid is used as a topical anti-infective agent in the preparation of various dusting powders, antiseptic creams, and ointments, etc. Boric acid is used in the preparation of buffer solutions for topical medications to maintain the acidic pH. That's all for today's topic. Thank you.